Hello, physical science class. This is a short video that I'm putting together to help. I've noticed a few difficulties with questions 11 and 12 on page 425. I just want to go over again what an electron dot notation is. Always includes just the valence electrons. Okay, and that is the electrons that are in the outermost shell. Okay, so think about on your periodic table, wherever there's a material that's got an A at the top, right? So that's 1A, 2A, 3A, 4, 5, 6, 7, 8A. Each of those A's and numbers are telling you that the materials that are in that column have that many valence electrons located in them. All of the elements that are in this transitional element section here are going to all have 1 to 2 valence electrons in them, and we're not going to really probably deal with them as much right now because we're in the learning phase. So I want to go over then what that would look like, right? For example, sodium. If I were to ask you to write what the electron dot notation is for sodium, let's see if I can get it here so we can look at it. Its abbreviation is Na, capital letter for the first letter, lowercase for the second. Sodium is going to be in group 1A. That would mean the only thing you would write for its electron dot notation would be Na with 1 dot. On the other hand, if I were looking for something on the other side in the non-metal section, like for example chlorine, chlorine has it's located in group 7A, so it's got 7 valence electrons, and I'm going to show those by X's. Okay, you could do it with dots just as well, but my purpose is to be able to make an application for a combination of these when we get to this section. So all you have to do to write an electron dot notation would be to show the element's symbol and however many valence electrons that it has around it. So when we're looking at it, the most number of electrons that an element can have is only 8, right? I wanted to show how you can utilize this for the representation of Lewis structures. Okay? Lewis structures are meant to show the bonds and the sharing or the giving and taking of electrons that are involved in the bonding experience. So when I look at an ionic compound, if you remember from the last chapter, a little bit of review here, ionic would mean you'd have something that's a metal bound together with something that's a non-metal. Okay? Remember, the valence electrons of an element that only has 1 means that's going to tend to want to give away that excess electron, right? That outermost shell of electron. It would be kind of like, if we thought about it, this element says, if I got rid of that 1 electron, I would have my perfect 8, right? I would have my perfect octet. So they're going to look to want to give away that electron to something else. Say, for example, chlorine on the nonmetal side, having 7 valence electrons, it only lacks 1 from being its perfect 8, right? So we could think about it, this element, sodium, is going to love to give away its excess valence electron to chlorine. And chlorine is going to love to take that excess valence electron, because now when these two combine together, we're going to see a combination here that's going to represent sodium chloride, or we could write it this way, these two elements are sharing one pair of electrons. So sodium chloride table salt is going to be written like this. This would be a dash to represent the bond, the one single bond that's happening there. And this would show the pair of electrons that's being shared in the process. I just wanted to show you in question 11 on your homework on page 425, it does not tell you this topic or this name, diatomic molecule, but we did talk about that, and that's really what 11C is talking about. Okay, in 11C, you've got bromine that you are going to write the electron dot notation. That's the same thing as when we look at chlorine being a diatomic molecule. If we were to write chlorine in its electron dot notation, we would think about chlorine in the diatomic molecule is searching out another chlorine that's also in the same boat. Both of these elements are lacking one from their perfect 8 or octet, right? So if we thought about it, this one and this one, I like to think about it kind of like a Reese's peanut butter cup, right? One of my favorite chocolate peanut butter combinations. When we think of chlorine and chlorine, they naturally pair together to create a diatomic molecule, right? These two chlorines are going to share. This chlorine, in essence, has something that this chlorine needs, and this chlorine has something that this one needs. So they're going to naturally share a pair of electrons and be a diatomic molecule. So right now, the way I've drawn this, it looks like this should be double, but it's not, right? Because this one is fitting into, kind of like a seat belt, clicking into place, is clicking in here, and this one is clicking in here to create a bond that's going to share one pair of electrons, right? That represents a diatomic molecule. For a covalent molecule, say for example, I guess I'll just pick 11A here, or sorry, 12A here. This one here, what we're going to do is to write out each of the elements that are combined. And I want you to look at how they have written out each of these situations, right? When they write out in this question a C and a Cl4, that means you have one carbon and 4 chlorines. That's 4 means tetra. Tetra means 4. So carbon tetrachloride is one carbon with 4 chlorines. So I'm just going to try to write it kind of quickly here. You would be writing out what each of these electron dot notations are and using this information to help you write a Lewis structure, right? So what you need to do is look at all of the elements that you have. Write them out, right? How I found them was to look at carbon. It's in group 4A, therefore I know it has 4 valence electrons. 8 minus 4, that means it needs 4, right? Chlorine is in group 7A. That means it has 7 valence electrons. It only needs 1. So I'm going to think about this chlorine as giving up, each of these chlorines as giving up a valence electron to help in the match here, right? You're going to have essentially carbon with a chlorine on each side bonding and sharing a group of electrons. So you're going to be able to write it kind of like this, and this would be your Lewis structure that shows that combination. Okay? Thank you. Hope this helps. You can contact me if you have any questions.